Welcome back, students. During this class, we will study about latent heat of vaporization of water. So, we will define latent heat of vaporization, then we will see what type of symbol is used to calculate the latent heat of fusion, and then we will see how to calculate latent heat of fusion. So, here it is. When the water is heated, it boils at 100 degrees Celsius. Under standard pressure, its temperature remains 100 degrees Celsius until it is changed into steam. Its latent heat of vaporization is 2.26 into 10 to the power 6 joules per kg. That is 1 kilogram of water requires 2.26 into 10 to the power 6 joule heat to change it completely into gas or the steam at its boiling point. What happens basically, this is the most important thing to understand. What happens when we are trying to change water to steam or the gas form? Why the temperature of the water surface is constant? The reason is very much simple. When you start heating water at boiling temperature, the temperature of the water at boiling point remains 100 degrees Celsius. Huge, the large amount of heat energy, the much more the water molecule gain energy, they move up to the upper surface and burst from the surface and release the excess amount of energy in the surrounding in the form of steam. So that's why the temperature of the surface remains constant. This is logical to see that how the temperature of the steam remains constant. So what happens when we heat liquid at boiling temperature, that is 100 degrees Celsius? Molecules of the water gains more amount of energy, heat energy, and after gaining more amount of heat energy, why the temperature of this boiling water remains at 100 degrees Celsius and it is gets converted into steam? Because the amount of heat energy carrying the molecules which are carrying more amount of energy, they escape out from the surface of the liquid and burst outside. With bursting, they release the amount of heat energy to the surrounding, and then again the temperature of the water surface remains the same. So this is the reason why the one form, that is liquid form of the water, is converted into gaseous form, but the temperature remains at 100 degrees Celsius. How much amount of heat energy is required? How much energy is required to change it? That is 2.26 multiplied by 10 plus 6 joules per kg. So this is the most conceptual thing to understand. So moving ahead, now take the boiling water and heat it till the time it changes into steam. The time taken by the boiled water to vaporize into steam is known as this graph. We will see, we are going to discuss this graph. We can calculate the latent heat of vaporization of the boiled water with the help of given data. So look at this. This is along this it is taken time. Along y-axis it is taken as temperature. So you increase the temperature from 0, and when you reach up to minus to 0 degrees Celsius, then at the same time the water is converted from solid ice into water. And again, when you start heating, this water is temperature of the water increases from 0 and reaches up to 100 degrees Celsius. So basically this one is, let's mark it here. So this is the point where the temperature of the water is at 0 degrees Celsius and 100 degrees Celsius. And here is the point where the temperature of the melted water from solid ice to water, that is 0 degrees Celsius. It remains constant for few minutes. So after the time when the whole ice is melted into water, then we again started heating. With the time passage of the time, when you started further heating, heated the water, then its temperature increases, and the time reaches where its temperature becomes 100 degrees Celsius. At that time, the water starts boiling, and this is the time when the excess amount of molecules carrying excess amount of heat energy, they escape out from the surface of the water by giving it their heat to the surrounding, transferring their heat to the surrounding, and the temperature of this water remains at 100 degrees Celsius when it gets converted into steam. Here it is at 8 minutes, then look up to 38 minute where it starts converting from liquid to gaseous form of the steam. The temperature remains at the constant at 100 degrees Celsius. And I have already given detail why the temperature of this water surface remains the same during its boiling because the number of molecules which are getting more amount of heat energy, they escape out from the surface and they burst outside. Then bursting, they release their excess amount of energy to the surrounding. So this is the reason why the temperature remains a constant. And due to this reason, it is called latent heat of vaporization. So this is the calculation of latent heat of vaporization by using this data graph time taken from 0 to 100 degrees Celsius, and that is T3 minus T2, and the time taken from the graph is this one. If you look at the time taken by the water at 100 degrees Celsius to change into steam, that is this one. This was the time. If you look at back at the graph, these are the values taken from the graph. The specific heat of water C increases in the temperature of the water in the, that is delta T. It is from where you have increased and you reached up to 100 degrees Celsius. So what's the formula to calculate latent heat? That is, this is del Q, that is MC del T. So this is the specific heat of the water when it remains at a constant temperature and when it starts converting from liquid to gaseous form. Further, we will start from this point after this point, that is this one. As Hamza supplies heat del Q to the water in temperature T1 and PO to raise its temperature from 0 to 100 degrees Celsius. Hence, the rate at which the heat is absorbed by the beaker is, so this is at constant temperature because at constant temperature the water starts converting from liquid to gaseous form. So this is called latent heat of vaporization, and it is calculated by using this amount, how much amount of heat energy you are given, at what temperature you are given to convert it into steam. So here it is heat absorbed in time. What was the amount of heat absorbed in during which time? This is the formula to calculate. And here it is the latent heat of vaporization. Del Qm HV, and this HV is basically calculated by using this formula. And you put the values in this formula, you will be getting the latent heat of vaporization of the liquid. But first of all, you have to draw the graph, and after drawing the graph, you will get values from the graph, and finally you will be able to calculate do the calculation to calculate the latent heat of vaporization of the liquid. Basically, what it is basically at the time when the liquid starts converting into gases at constant temperature. How it's happening? It happens when high energy molecules move up to the surface after getting energy at the bottom. They burst out from the surface by releasing their amount of energy to the surrounding, and by this way, the temperature of the surface remains the constant when it is converted, liquid is converted into gaseous form. So this was the concept of latent heat of vaporization. Latent heat of vaporization of water is found by the above experiment, that is 2.23 multiplied by 6 joules per kg, while its actual value is this one 2.26 multiplied by 6. So with this our class ends. I hope you people have understood the latent heat of vaporization. Thank you very much for your question.